Welcome to the channel Physics Made Easy. We are discussing the phenomenon of refraction. You know, sunrise and sunset are two beautiful phenomena. Everybody wants to observe it. Do you know what time before we observe sunrise and what is the time delay we observe sunset? You know, actual sunrise means the actual crossing of the horizon by the sun. But we don't see the actual sunrise. Then how much delayed sunset or earlier sunrise we observe, we will discuss. Along with this, few more examples based on the refraction we will discuss today. So stay connected. You know, we have read previously refractive index relation with real and apparent depth. Today we will discuss sunrise and sunset phenomenon in the refraction topic, that is the cause of sunrise and sunset is the atmospheric refraction. We observe delayed sunset or advanced sunrise due to atmospheric refraction as well as rotation of earth about its axis, axial rotation. Suppose this is earth and this dotted circle is the atmosphere around earth. What happens? A person who is standing here, and for that person he is watching, this is the horizon or horizon. The sun, its actual position is, if I show here, then due to atmospheric refraction it has been observed that on the till this point, till the visitor or observer, the rays due to atmospheric refraction bend like this. And what happens if they are extended back, then the apparent position of the sun is supposed to be observed here. This is actual sun, actual position of sun, and this is apparent position of sun. Okay. So what happens? From the sun, these rays which go through the atmosphere, they bend in such a way, due to this is called atmospheric refraction, that on extending back they appear to come from this point. And you know, the shift between actual and apparent position, it has been observed that time difference of 2 minutes or half degree, that is equivalent to half degree, this angle is estimated for the actual sunrise or an apparent sunrise or actual and apparent sunset. How it has been calculated? Look, due to axial rotation we find 360-degree rotation of earth corresponds to which time? 24 hours or 24 into 60 minutes. Then for 1 degree, what will be? For 1 degree rotation, what will be the time difference? That is 24 into 60 upon 360, that is 4 minutes. It has been observed that time difference of actual position and apparent position of the sun is in degree half minute or in time 2 minutes. In degree half degree, that is half degree is equal to 2 minutes. So due to axial rotation of earth and atmospheric refraction, we see the sunrise in advance 2 minutes earlier before the actual sunrise, or delayed sunset 2 minutes due to the atmospheric refraction and rotation of earth about its axis. Another example based on refraction we will discuss today: normal shift due to glass slab. We have read earlier in previous video that N2 upon N1 is the real depth upon apparent depth if the observed in denser medium is placed at somewhere and if it is observed from other medium, then it appears to be slightly raised. Then its real and apparent depth ratio we calculated earlier. What today we are going to discuss, that is for normal shift. What is this normal shift? Let us discuss. Suppose this is the glass slab. Okay. If this is the position of object O, glass slab has these two surfaces, so the ray from the object will be refracted 2 times. This is from the first surface and this is from the second surface. Suppose what happens that a ray which is incident at the first surface at this point, what will happen? You will draw the normal, and here suppose it is air, here also it is air, and it is glass. So what will happen? Rarer to denser medium, as we have seen, it will bend towards normal. So the ray will bend towards normal, that is in this way. If it is extended back, then its image or the position of first image, that is I1, it is shown here. Okay, how it has been shown? Look, that the ray which is going from O to the denser medium is due to refraction, it bends towards the normal. Then on extending back, if you observe from here, what a person will observe? That the image of O is here, this is I1. At I1, image of O is observed. What will happen at this point? Again the refraction will take place, so from normal. Now what will happen? The ray will go from denser to rarer medium, so it will move away from the normal. So it will move away from the normal in such a way that on extending back, if you extend back, then it is supposed to be coming from here. Okay, so this is the position I2. So what we observe here, that the ray is going from denser to rarer medium, and in this case at the second surface and at the first surface from rarer to denser medium, both side air is present, and this is the refractive index mu of glass. Suppose this point is A, this point is B. What is normal shift here? This final image as observed from here, if it is observed from here at the second surface, the final image is I2, actual object, its position at O. This OI2 is called normal shift. What will be its value? How to calculate? Look, let us suppose that this distance of object, that is OA, is x, and thickness of the glass slab or slab is T. As you know, in this relation N2 upon N1 is real depth upon apparent depth. For the first surface, if you apply this relation, then how will you write? You know, N2 is that medium, refractive index of that medium in which the object is situated. Where is the object situated? Here. Then you will write here this 1 upon N1 in which the rays are going. So this ray is incident from O and it is refracting in mu. So this is 1 upon mu equal to real depth. What is real depth? X upon apparent depth, suppose d dash. This implies that this apparent depth will be x mu. Suppose this is the first expression. Now for this ray which is incident at this second surface, from where it is coming? Look, this is coming from I1. Actually, this I1 is acting like the virtual object. For second surface, the distance, the real depth, what will be the real depth? Look here, this I1 from second surface. So, for second surface, what will you write? Real depth. Real depth will be I1 to B. What is this? T, and what is this? D dash. D dash is x mu. So you have written x mu. So this B to I1 total is the real depth for this surface. So that is T plus x mu. Now again same formula is applied here for mu to this air. If you apply the same formula, look here, N2 is that medium from where the rays are incident. So rays are incident here. What will you write? This from mu to air. So what will you write here? This will be mu upon 1 equal to, this will be real depth, that is T plus x mu upon apparent depth. Suppose again this is d dash. This implies that d dash is T plus x mu upon mu. This is the expression number 2. This d dash is what? Look, this d dash is the position of I2 from B. This is the d dash in the second case, or we can write the value T plus x mu upon. Therefore, the normal shift. How will you calculate this normal shift? Here it is O to I2. So this OI2 normal shift can be written as this BO minus BI2. You can write here, this is BO minus BI2. What is BO? This T plus X. Normal shift, if it is represented by S, then S will be equal to T plus X minus BI2. What is BI2? This T plus X mu upon mu. So S will be equal to T plus X minus T upon mu minus X. So X will be cancelled. If you take T common, you will get T minus 1 upon mu. T into 1 minus 1 upon mu. This is the formula for normal shift. Where this, in this relation, what are the assumptions or important points which are to be noted? You can note down. First one, that we have taken the rays paraxial. Rays are paraxial means these rays are parallel. This one and this one. This distance is very, very less. Second thing, medium on both sides of the slab is same, look here, this is air, and if medium is not air, then in this relation you will write shift will be equal to T1 minus mu surrounding upon mu of slab. Okay, because if surrounding is air, then mu surrounding is 1. Third thing, and that is very important, that if this shift is positive, what does it mean? That shift is taking place in the direction of incident rays. That is here, if shift is positive, then in the direction of incident rays somewhat where? At these points. And if shift is negative, then it will take in the direction opposite to the incident rays. So positive shift in the direction of incident rays and negative shift in the direction opposite to the incident rays. Now we will see this question. In this question, a slab of 10 centimeter thickness and refractive index 1.5 is taken. An object is placed at the distance of 15 centimeter from this surface. Surrounding medium is air. Then you have to calculate the shift, and if the surrounding medium is refractive index 2, then calculate the shift. Let us see first case. Shift is given by T within bracket 1 minus 1 upon mu. If air is surrounding medium, this is air, refractive index of air, it has been assumed 1. Then in first case, what will be? This will be equal to T, what is this? 10, 1 minus 1 upon 1.5. You will get this 10 into 1.5 minus 1.5 upon 1.5. This is 3. So you will get plus 10 by 3 centimeter. So if the ray from the object moves like this, then in the direction of incident ray at somewhat here, this will be the shift. Okay, 10 by 3 centimeter as it is positive. In the second case, again, what is the shift relation? This is T1 minus mu surrounding upon mu slab. What will you write here? This is T 10 centimeter, 1 minus 2 by 1.5, as mu surrounding is given 2. Then what will you get? 1.5 minus 2, that is 10 into minus 0.5 upon 1.5. So again, what will you get? This is minus 10 by 3 centimeter. Minus means opposite to the incident direction. Incident ray is in this direction, then at somewhat here, this will be the minus 10 by 3 centimeter. This will be the shift. So positive and negative shift, how are they calculated? We have seen. We will see the case of composite slab. Composite slab means there are 3 slabs of different thicknesses and refractive indices. The gap between them, this is between first and second, gap 1, and this is the gap number 2. Okay. Object is placed here and all medium, this one here and last, air. Note down that net shift, if you write S net, what will be the relation for that? From the first slab, the shift will be S1, then from the second it will be S2 and then S3. What will be S1, S2, S3, its value? You will write T1, 1 minus 1 upon mu. Why 1? Because air is there on both sides. Similarly, for second one, T2, 1 minus 1 upon, this is mu 1, then this is mu 2, and finally T3 within bracket 1 minus 1 upon mu 3. Here in this case, first and last medium is important only. If these medium, first and last one, they are same, then whatever is the medium between these gaps, it doesn't matter, it doesn't affect the net shift. One thing, also the gap between the slabs doesn't matter at the result of net shift. So how to calculate net shift? One way to find the refraction from the first surface, then second surface, then take the difference, you will find S1. Then similarly for the first surface and second surface refraction from second slab and then from third slab, it will be very complicated. How to get the result directly? By using this relation. Here if you put the value, suppose I have written here, suppose you can take mu1 equal to 1.5 refractive index of first slab, and second slab suppose 2, and for the third slab suppose it is again 1.5. Thickness, if we can write here thickness for this one as suppose this is 21 centimeter, this is 12 centimeter, this is 9 centimeter, different thickness. Then put the value and get the result. You will get here this T1 as 21 into 1 minus 1 by 1.5. Similarly, this is 21. Okay. Then second one S2, what will you write? 12 into 1 minus 1 by 2 plus 9 into 1 minus 1 by 1.5, and you will get the result. This is 0.5 upon 1.5, that is 1 by 3. So 21 into 1 by 3, this is 7. Plus here this is 12 into 2 in 1 by 2, so 2 6. Plus here again 0.5 upon 1.5 will be 1 by 3. So 9 into 1 by 3 is this 3. So what is the total? This is 7 plus 6 13, 13 plus 3 16. This is 16 centimeter. That means from the object at the distance of 16 centimeter, the net shift S net is calculated. So how it has been calculated and what are the points to be emphasized? Note down that only the first and last medium matters. There may be any gap between the slabs. It doesn't affect the S net. Also, whatever may be the refractive index between gap, it doesn't matter. So in this way, you have to find the net shift through composite slab. In this video, we have seen atmospheric refraction, the refractive index of air with respect to vacuum 1.00029, and due to that the delayed sunset and advanced sunrise. What is the reason behind that? We have seen. Also the normal shift through glass slab. It will be very helpful in your examination point of view as well as to discuss with others. I hope you must have enjoyed it. Thank you.